Good afternoon, everybody. I'm Feng Li. I'm very glad to have an opportunity to give a talk on DConf Online this year. The topic that we are going to share today is about the DBase next generation verification language Vlang. Here is a brief introduction of myself, and this is the URL of my GitHub, where all the slides of my talks can be found. Firstly, let's take a glance at the agenda, which is divided into 5 parts. The first part describes the technical background. The second part is an introduction of the architecture and design of Vlang. The third part is about our effort for porting Vlang to ARM. The fourth part is the future trends and our plan. And the final part is the wrap-up. And let's get started. As we know that the free and open source EDA is growing very fast in the last decade, which is mainly driven by the booming of RISC-V and so on. We are always using hardware description languages for hardware development. This figure shows the evolution of HDLs during the past decades from our point of view. The latest trends indicate that EDSL, which means embedded domain-specific language, is becoming much more popular. The main advantages of EDSL are more easier to leverage the existing ecosystem of its host language and let the developers of its host language get started. Here is a list of some well-known EDSLs for hardware development according to different host language. Hardware verification plays a similar role as the software testing, while touches at hardware design. There exist some specific languages for hardware verification, which is known as HVR. For example, System Verilog is a well-known HVR. Although there are many different approaches to achieve hardware verification, EUVM, which means Universal Verification Methodology, is the de facto standard in the industry, and its reference implementation is also written in System Verilog. There still exist some solutions that do not follow EUVM, but are widely being used in force EDA. CocoaDB is one such project. With the help of CocoaDB, developers can write test benches in Python, which greatly lowering the barriers. Our main test bed is Raspberry Pi 4 with the latest release of Fedora. Here is our software environment. The latest toolchains that we installed on Fedora, and the development tools for D language, which will be introduced later. Fedora is our favorite Linux distribution, since it is developer-friendly, especially for offering official support on Raspberry Pi 4 devices. We are using LDC in development work. Actually, the latest binary release of LDC for ARM64 does work properly on Raspberry Pi 4, but we still decided to build it from source on our testbed in order to verify if Vlang can work with the upstream D language. We just follow the official guide to build LDC from the latest source code and successfully got it working on Raspberry Pi 4. But the outputs lack of some utilities and library. For example, the dub tool. So we have to install it with the package management tool on Fedora. Now let's quickly go through the architecture and design of Vlang. Please note that some materials from the original design documents of Vlang that listed in this section may be a little out of date. This is the original paper of Vlang. Vlang was created by some experts from India and NSP. It follows a top-down design methodology which is different from many traditional solutions. Here is an illustration of objects hierarchy and packages design of Vlang. This is the concept of processes in Vlang. Vlang uses the features like mixing and user-defined property in D language to implement constrained randomization. We can use Vlang to achieve a multi-core-friendly EUVM implementation. Vlang works well with System Verilog and System-C. The subsequent development and maintenance of Vlang is growing slowly. Now the Indian company that behind the Vlang sets up a new website for it and starts a new project EUVM, which aims at running Vlang-based UVM on embedded devices such like Raspberry Pi. But it seems that they are still far away from their goal. Project Vlang has now been split into two sub-projects. Its core part becomes ESDL, which means the Electronic System Description Language, and the rest becomes EUVM, which stands for Embedded UVM. Here are some core concepts in their latest design. This is a short introduction of Project ESDL. And this is an overview of Project EUVM, which depends on ESDL. Here is a summary of the current status of Vlang. It only supports UVM 1.0. Project ESDL and UVM are lacking of documents and test results. The latest all-in-one release of Vlang touches x64 only. The ESDL part and the rest follows different license. The total size of all files in this release is large, as the debug versions and LDC are included. Anyway, ESDL and UVM provides a good reference of design and code base for us. Now let's do some experiments to try to port Vlang to Raspberry Pi 4. As you can see, we are using the LDC version that is built by ourselves as mentioned before. We could meet the following error against the source library when trying to build the latest source code of Project ESDL without any change. Let's check the package description file and apply a workaround like this. Then another issue, unable to read the module malloc comes, which because of its implementation is missing. We temporarily replace module malloc from ESDL with what in Phobos to bypass it. After that, we will meet another unable to read the module issue. Actually, module array is even unused this time, so we just comment the code that imported it. Subsequently, we will meet a similar issue of module allocation, and we just apply the same change to it. At last, we could successfully build Project ESDL on Raspberry Pi 4 with the above changes. The final outputs are listed here. It is strange that we only get a static library, but the dynamic library is missing. When trying to test Project ESDL, at first we could meet an error of failed to import a module. After add the missing module path for it and retesting, more errors will come, as below. We are still working on fix all the issues in ESDL testing. Then let's take a try to build Project EUVM. It's sure to meet the following errors when trying to build the native source code of EUVM without any change, which because of the dependency package ESDL is missing. This is the package description file of EUVM, and let's add the path of Project ESDL that we built previously to it. Then we will meet another strange issue that the deflags for position-independent code is unknown to LDC. We do not know what's wrong with the LDC here, but have to remove this flag to continue. Then a lot of forward reference-related errors will appear. We are still working on resolve these issues. As you saw before, it is obviously that there is still a lot of work left to be done to make ESDL and EUVM really does work on ARM devices. Here comes our future work. As we can see, current industry trend is distributed simulation, which means test benches will not only be running on a multi-core machine but also across a cluster. And is it time to thank EUVM and say goodbye? From our understanding, CocoaDB stands for the feature of hardware verification in force EDA in some extent. So in our current plan, the first thing is trying to replace the C++ code in CocoaDB with D language. Finally, let's give a summary of this topic. It's a new golden age for ForceED. This is already showing its potential for the next generation system programming, including the hardware and software collaboration, but still has a long way to go. Many D-based open source projects may not be well tested outside x86, while we should pay more attention on ARM and RISC-V. First, let's enhance LDC to better support for ARM, RISC-V, WASM, eBPF, and SPIR5. If you are interested, you may refer to our previous talks and the upcoming follow-ups at my GitHub as mentioned before. Thank you for listening. That's all.